Today, I want to talk about all the things that I learned in my first year of being a full-time software engineer. I mean, it's only been a year, but so much has happened that I felt that it is a really good time to summarize all the things that I learned. After all, with so many people aspiring to become software engineers, this musing of mine might be insightful to many. This video will not be structured in the same way as the rest of my videos, since I can't really break it up into multiple separate parts. Instead, I will simply bring up the 10 things that I found to be particularly insightful realizations over the last year. With that out of the way, let's begin. Alright, let's begin with the very first thing that I feel that I found to be particularly insightful. Learning how to use the code search tools properly is incredibly important. At our company, we use an external tool for code indexing and searching, and that tool has surprisingly shoddy documentation in terms of how to actually use it beyond what you can infer from the main page. For about 3 months, I couldn't figure out why it just felt so awkward to use and why it just seemed so difficult to find what I was looking for. Eventually, I decided to spend a couple hours scouring the web for an explanation of how to use it and came across a tiny GitHub gist that was a goldmine of useful information. Suddenly, I knew how to make compositional queries, filter results by programming language, and even include or exclude some file system paths to further filter out results. That marked the point when I got significantly faster at finding certain types of information. Therefore, some advice from me is to take a moment and really learn the tools you have at your disposal, especially when it comes to tools that search through large code bases. Alright, let's move on to the next point. Personal growth comes at a cost, or rather, it's not really free. Here is what I mean. Real growth comes from effectively stepping outside of your comfort zone. This is difficult and will always come at a cost. For me, that cost is actually increased stress load, which can lead to anxiety and feeling overwhelmed at times. However, the rush of figuring out the problem that you didn't think you could do before is quite nice. Anyways, while we're on the topic of stressful things, another thing that I learned is that learning to manage stress is insanely important for the longevity of your career. This is something that took me a very long time to really figure out, and even longer to make it a priority to actually figure out healthy ways to relieve stress. I heard this from so many sources. It is incredibly common for developers to just burn out, and once you burn out, it is difficult to recover properly. I decided to be proactive in terms of avoiding burnout, and therefore I started to meditate and exercise often, both to feel better in general and for stress relief. I have to say, it's quite incredible just how well doing some basic exercises combats stress. Honestly, meditation is an odd one too. I thought that it was a bunch of nonsense for a while, but when I started to do it, I noticed just how much quicker I started to take setbacks and other dumb things outside of my control in stride. Okay, let's move on to another source of stress, and another thing that I learned. I know almost nothing, and that's okay. This might be an odd one to see someone admit to, but I think that all developers come around to it at some point. Either way, we tend to severely underestimate what we know and understand, so the issue is typically worse in your own mind than it really is. Another thing, nobody's actually expected to know everything. That is why we have people specialize on just some part of the code base in each team. The more important thing to know is where to ask for help in situations where you don't know how something works. Either way, over time we build up a mental map of who is a subject matter area expert, and that map of who to ask and when becomes incredibly valuable. Let's also not forget that it is next to impossible to actually know everything. Therefore, it's perfectly okay to know next to nothing, especially when compared to the insane body of knowledge that exists out there. While I'm on the topic of things that seem like they might not be okay but really are, sometimes things go wrong, and that is also okay. Here is a personal anecdote. I made some changes that modified the way a process starts up and under what name. The automated tests passed for all my changes. The changes were vetted by multiple people and eventually they merged into the main line. About 6 hours later, I get an email that basically says that, hey, your changes broke ASU. The pass rate on tests is hitting 0%. To say that I was mortified to have caused an outage of that scale is to say nothing. However, the process to resolve the problem was to just use the infrastructure already in place to revert the changes and start the investigation of what was the underlying issue that caused the features to break in such a spectacular manner with my seemingly unrelated changes. I can't talk about what the solution was, and that's not relevant for the discussion anyways. What is relevant is that there was infrastructure already in place to fix the issue ASAP. And it's in place because sometimes things go wrong despite following all the protocols and best practices. Test suites will always have gaps. Lapses of judgment will happen. Things will go wrong, and that's okay. While we're on this topic, another thing I learned is that the best way to learn something is by doing and not by reading. Here is what I mean. While it is important to have an understanding of what you're about to do before you do it, if you spend too long just reading code, especially in a massive code base, you are very likely to get affected by analysis paralysis. Once you get paralyzed that way, you are unlikely to actually get anything done for a long time, while thinking that you have a bigger grasp of the problem at hand than you likely actually do. For example, I now have a deeper understanding of ASU than I honestly ever desired to have, and all of it being due to having to actually play with the feature to fix an issue I caused. Taking a step back, there is another reason for why you learn better by doing rather than reading. When you sit there actually implementing a solution to a problem, you hit underwater stones that you never would have even thought about. That causes you to truly learn what issues you can expect in the future, and even how to overcome some insane bugs. While we're talking about hitting underwater stones, I learned that code review is a thing to seek out, not avoid. Okay, to be fair, I learned that way before I started working full-time, but I got way more appreciation for code reviews with more exposure. While it may feel awkward to send out a review and get back a lot of comments telling you why you shouldn't do what you did the way you did it, that is actually an insanely useful thing to happen. Sometimes a fresh pair of eyes can catch issues that will lead to future bugs or even catch current bugs that your code introduces. Here is the thing. Nobody's code is perfect. It never will be, and code review is actually an incredibly valuable vehicle to get input from people that are far more experienced than you to learn from. I actually learned some incredible things that I've never even heard of before by seeking out reviews from my teammates. As an example, you can do some really clean comparisons of many objects in just one clean line of code using std_tie in C++. Here is a simple example of how that would work. Let's say we want to compare two cars that have a model name as a string, make year as an int, and a flag to represent self-driving capabilities. With std_tie, the comparison is super clean. Alright, while we're talking about code quality, might as well talk about the fact that if a piece of code is not tested, you might as well assume that it doesn't work at all. One of the first problems that I was given to figure out when I started to work was actually fixing a bug that was found in the code that I wrote during my internship with the company a year and a half prior to me starting full-time. This bug was mind-boggling. The feature was failing at doing the exact thing it was designed to do in the first place. After about a month and a half of investigation into whatever the hell was going on, I discovered the root cause. The underlying infrastructure changed ever so slightly, and the assumptions in my old code were no longer valid. The fix was trivial, removing a single line of code. However, it took a while to figure out how to write a test that would validate the assumptions about the system. How did this slip by us? Well, it was because we did not really think to even test the one assumption that underpinned the entire feature. To be fair, it took a lot of time to even comprehend that that was an assumption being made. But still, I have been taking testing and testability rather seriously after that. While we're speaking of assumptions that cause major issues, I learned that the more errors can be caught at compile time, the better. Here is the thing. You never know when the test infrastructure will let a simple bug pass through, or what feature interaction testing gaps exist. But one thing you know for sure, code that does not compile simply has no way to pass continuous integration jobs. This safety in having the compiler tell you when your code makes no sense is insanely important. There are two main ways that you can get the compiler to catch issues for you. First being static assertions, and the second one being compile time static code analysis. With static asserts, you can, for example, write a custom check to make sure that some buffer you made never gets instantiated at a size that is incompatible with other systems. That's neat, but requires thought. Compile time static code analysis through treating all compiler warnings as errors, on the other hand, does not require any thought at all. As an example, narrowing conversions are quite dangerous, but compilers catch narrowing conversions super easily. That's an entire class of bugs swatted just by turning up the compiler warning levels and treating the warnings as errors. Anyway, let's step away from code for a bit and talk about the fact that there are many ways to contribute to the company's success, and making software is just one of them. Well, this might not necessarily hold true in all companies, but I'm lucky enough that my company recognizes the fact that contribution can come from far more than just cranking out code all the time. This is actually quite important to me, as I did not want to let all the expertise I've built up in my previous endeavors go to waste. For example, I am currently heavily involved in recruiting from the University of Alberta. Reliable talent pipelines take a lot of time and effort to build, and my expertise that I built over 3 years of heavy student group involvement during my time as a student there is definitely valuable. When I was just starting out my work last year, I didn't quite realize just how much I will be able to use my existing expertise, and learning that there are many ways to contribute as a software engineer has been rather insightful to me. Now, I really wish I had the time to keep going and share more things that I learned, but I simply have to wrap up this video now. So, in this video, I shared 10 things that I learned in my first year as a software engineer. I learned way more than just 10 things, of course, but I feel that the things I shared here are the most memorable and important, at least from my point of view. Here is hoping that the next year of my career will be just as insightful, and I'm sure that I will be able to share more of my findings with you again a year from now. If you stuck around till now, then feel free to check out some of my other videos, and like this one if you liked it. Either way, thank you for your time. Bye.